Welcome to Quantum, How Everything is Made, where we uncover the science behind the ordinary. Today, we're demystifying the journey of aluminum, from raw materials to the foil in your kitchen cabinet. Get ready for a quick dive into the quantum realm of manufacturing as we explore how aluminum, the unsung hero, comes to life. Did you know that one of the world's most adaptable metals is aluminum? It's as strong as steel, but also as flexible as paper. Also, have you ever wondered how a large, solid block of aluminum is changed into a thin sheet of foil-like paper? Discover how the paper-thin aluminum foil sheets in your kitchen cabinet are made from millions of tons of processed aluminum. A Swiss business created aluminum foil in 1911, initially using it to wrap its well-known Toblerone confectionery bar. It eventually made its way to the food counters. This was mostly due to the discovery that aluminum possesses special barrier qualities that totally obstruct heat, light, and moisture. Due to the difficult nature of the extraction procedure, numerous scientists attempted to isolate aluminum up until the 18th century, but were unsuccessful. When they did succeed, it was just a little quantity of powdered aluminum. This meant that pure aluminum was more expensive than even gold because it was rare and required a labor-intensive technique to obtain. The discovery of electrolytic reduction marked a significant advancement in the manufacturing of aluminum. However, let's go back to the beginning. Bauxite, a mineral rich in aluminum oxide, is the main raw material used in the manufacturing of aluminum. Although clay also contains aluminum, bauxite is the major mineral in aluminum because it's far more affordable and easier to obtain. Open-pit mines, which are mostly found in tropical areas of the world, are the usual method of mining bauxite. Australia's Weipa mine, one of the biggest bauxite mines, produces 30 million tons of bauxite a year. Now, are you ready for the exciting part? Once we've secured our bauxite, the next act is refinement. There are multiple processes in the refining process. To create a slurry, the bauxite ore is first mechanically crushed, combined with caustic soda, and then run through a grinding mill. This slurry, a suspension of liquid ore particles that's extremely fine, is poured into a digester, a tank that works similarly to a pressure cooker. Under 50 pounds per square inch of pressure, the slurry is heated to 230 to 520 degrees Fahrenheit for a duration of anywhere from 30 minutes to several hours. To make sure all the compounds containing aluminum dissolve, you can add more caustic soda. A sequence of flash tanks is used to lower the pressure and collect heat from the heated slurry, which is now a sodium aluminate solution. This heat can be recovered and utilized again during the refining process. Following that, the slurry is pumped into a settling tank. Remaining contaminants in the slurry sink to the bottom and produce a residue known as red mud, which is made up of iron oxide, fine sand, and oxides of trace elements such as titanium. The residual liquid is pushed through cloth filters to catch any tiny particles of contaminants once the pollutants have settled. In order to recover alumina and caustic soda for future use, this material is cleaned. Did you think we were done? Not even close. Following filtering, the liquid is pushed through precipitation tanks containing alumina hydrate seed crystals. As the seed crystals grow, dissolved alumina sticks to them and they settle through the liquid. After the crystals precipitate, they are taken out, cleaned, and put in a kiln to be calcined. Heating is used in this process to break the chemical connection between the aluminum molecules and the water molecules. Following their exit from the kiln, the crystals go through a chiller. The link between aluminum and oxygen in alumina tends to be destroyed in order to achieve pure aluminum. Smelting, or the electrolytic reduction of alumina into aluminum metal, takes place in a steel container known as a reduction pot. To accomplish this, carbon is used to line the pot's bottom, serving as one electrode conductor, and carbon rods positioned above the pot serve as the opposing electrodes. Pot lines, made up of between 50 and 200 reduction pots connected in series to create an electric circuit, are the rows in which the pots are placed. Each pot line is capable of producing 66,000 to 110,000 tons of aluminum annually. Aluminum crystals dissolve in molten cryolite inside the reduction pot to create an electrolyte solution that transfers electricity from the carbon rods to the pot's carbon-lined bed. A crust forms on top of the aluminum when an electric current is passed through the cryolite. A layer of pure molten aluminum forms on the bottom of the smelting cell when more alumina is periodically stirred into the mixture, breaking the crust and enabling the alumina to dissolve electrolytically. But the journey doesn't stop there. At this point, additional components can be added to create aluminum alloys with properties suitable for the final product. Poured into direct chill casting equipment, the liquid aluminum cools to form big slabs known as roll stock or ingots. To create aluminum sheets, these ingots are mechanically processed to thin them out. Prior to being put through a succession of rolling mills that progressively thin out the metal, the aluminum ingots are heated. Several iterations of this hot rolling procedure may be required, contingent upon the intended foil thickness and characteristics. The aluminum sheet is cold rolled by passing it through the rollers at room temperature, then hot rolled to achieve the proper thickness and surface smoothness. The aluminum's hardness and tensile strength are both enhanced by cold rolling. The sheet may go through annealing, which is a heating procedure used to release the stresses created during cold rolling and soften the sheet, making it more formable. Are you still with me? We're nearing the end process. The particular procedure that will turn the cold-rolled aluminum sheet into aluminum foil is now ready to begin. Achieving the appropriate thickness, surface smoothness, and characteristics is the main focus of the foil rolling process, which is characterized by accuracy. To create thin aluminum foil, the cold-rolled sheet is fed through a sequence of foil rolling mills. These rolling mills can have several rolls that work together to gradually thin the sheet in order to guarantee even thickness and a smooth surface. To further soften the soil and preserve its ductility, allowing for further thickness reduction, intermediate annealing can be necessary. The aluminum foil goes through final annealing and finishing procedures to improve its qualities and guarantee a constant thickness. After that, the large foil sheet is divided into rolls that are narrower. These are the typical commercial sizes for aluminum foil. The foil is subjected to stringent quality control inspections at every stage of production to ensure that it meets the necessary standards for thickness, tensile strength, and surface finish. Weighing and measuring a sample to find its area, then dividing the weight by the product of the area and the alloy density yields the thickness. Now prepare for the grand finale. After the aluminum foil is made, it's cut into different standard-sized rolls or sheets based on the needs of the customer and wound onto huge rolls. To be distributed to manufacturers, merchants, and other end users, the finished aluminum foil is packaged and labeled. It's important to remember that metal is extremely recyclable, and recycling leftover aluminum helps make aluminum foil. Recycling is the process of melting down discarded aluminum goods and processing them again to make foil and other new aluminum products. This recycling method uses less energy and lessens the influence that aluminum production has on the environment. That's a wrap for today's episode. If you found the magic of aluminum intriguing, hit subscribe, like, and tap the notification bell. Stay tuned for more quantum revelations on Quantum, How Everything is Made. Until next time, keep questioning everything.